Right, so if we'll move on to our next session, I'll give the guys who were on that Zoom call a chance to get back into the main into the main session. But next we're going to switch over to another kind of different technique, a fireside chat. And in this fireside chat, we've got Carol Fletcher from BT, and we've got Dr. Alastair McGibbon, who's the head of collaborative R&D at the Compound Semiconductor Applications Catapult. So there's some really interesting insights here in terms of the semiconductor industry at the end of the day. Thank you.
Hello, I'm here with Alastair McGibbon from the Compound Semiconductor Applications Catapult, who's going to tell us a bit more about the Catapult model and how it's delivering value through industry and academic collaboration. So Alastair, can you tell us a bit more about the Catapult model and how it works?
Okay, yeah, hi Carol. So the Catapults are research and technology organisations in the UK, so they're core funded by UK government, and they're there where there's a gap between academic capability and the exploitation of that capability into industry. So we're there to sort of draw that through and be able to help companies develop products and innovation and IP in specific technology areas. And usually those areas are where there is UK capability and there's the opportunity for market growth. So for example, there's a dozen catapults or so in the UK, some of them in transport systems, offshore renewables, digital technologies, manufacturing. So most of the catapults tend to be vertical sector oriented, so say in offshore renewables or energy systems. But we ourselves are in an enabling technologies catapult, which is quite unusual.
And can you tell me a bit more about the Compound Semiconductor Applications Catapult? So what's the remit of the catapult and who is it that you're collaborating with?
Okay, so the CSA Catapult, our remit is we work in enabling technologies. So compound semiconductors, there's a lot of UK capability in those materials. So normal semiconductor systems are silicon based. That's people familiar with silicon chips. But there's a lot of semiconductors which are not silicon, like gallium nitride, gallium arsenide, 3,5 semiconductors. And they're also extensively used in different electronic applications. But they tend to be in more niche technologies. There's a lot more IP needed to actually develop systems with these semiconductors in them. Okay, so the UK's got a lot of capability in that space, from fabs where they actually develop the devices with the semiconductor chips with in wide band gap or 3.5s or whatever, but all the way through up into system integration, design, and into application space. So, and there's a lot of growth opportunity there. So that's where we sit. So we sit in that space, helping that whole supply chain in the UK develop solutions for their non-silicon compound semiconductor-based systems. So in a way, you could say that the CSA Catapult is an advanced electronics catapult. So we work in the application space where a lot of these non-silicon semiconductors are. So that's primarily power electronics, photonics, sensing, quantum technologies for a lot of non-silicon, and RF and microwave. So in applications speak, that's primarily power management for net zero, intelligent sensing, and advanced communications. So there's a lot of challenges to be had in working with the supply chain to develop solutions in these areas. And one of the issues is that if you think of the silicon market, it's very mature. It's been 50, 60 years. There's been a lot of investment of it. You've got foundry models where you basically got these huge silicon foundries in the Far East, and you just have a process and you can have this chip that can go into lots of different applications. Compound semiconductors is not like that. It's much more bespoke. It's not plug and play. So there's a lot of optimization to be done in the system optimization to be able to make the systems with those semiconductors in them work as well as they're supposed to do on paper. So, and to be able to do that, quite often you're working with multiple companies across the supply chain as well. There's not necessarily a single integrated company. So you're pulling together all these different bits of IP, co-design, developing the sort of system where you all these different variables, and optimizing it in a way that eventually it can be suitable for market and you can make product out of it and it's cost effective. So we do that in photonics, RF, power electronics.
Brilliant. And can you tell me about some of the successes that you've had in the CSA Catapult and the kind of value that it's been able to deliver?
Well, we're a relatively young Catapult. We're already been pretty successful, and we're probably in about 30 different collaborative projects all in. And it's important to say when you look at the supply chain in the UK, so that's all levels of the physical supply chain from semiconductor through to manufacturing, but also there's a very important and capable UK research base there as well, who are in the enabling technology such as this. They tend to be quite industrially focused groups in universities as well. So we work with them, with industry, to help these. So in terms of some of the projects we're already in, I think by far our biggest area to this point so far has been power electronics. We're also in a lot of interesting comms and sensing projects, but in power, because net zero is so important at the moment, there's always been, like I said, the silicon industry. I think there's something like $1 trillion invested in silicon development over the years, right? So if there's a way silicon can do it, silicon will do it. But at the moment, if you look at power electronics, there's what we call wide bandgap based semiconductors, gallium nitride and silicon carbide. You can get very high power density power electronics, so much more than you can in silicon, and it also is very good for harsh environments. So what's now happening is, and very unusually, you've got a situation where silicon can't do it. And if you look at, say, vehicle electrification, so next generation EVs, so rather than having a motor, you'd be, well, you've still got a motor, but you've got an energy storage that could be hydrogen or it could be batteries. You've got an e-motor for the electric vehicle, but in between you've got the power electronics that has to be very efficient, very high power density, very flexible in these electric vehicles. And it turns out that materials such as silicon carbide and gallium nitride for the chips are very well suited for next generation electrical vehicle deployment. And you're already starting to see that happen. So for example, the Tesla Model 3 that's out there, the power electronics for that is silicon carbide, not silicon. So all the automotive companies are starting to move to those technologies, but it's still early days. There's a lot of development work and optimization to be done. So one of the projects we're in fact, several projects now, is we work with both the tier one suppliers and the OEMs in next generation electrification to optimize the power electronics development. There's wide bandgap based power electronics for EVs. So we're in a project, for example, called Escape. Escape, there's some fab capability in the UK to actually make silicon carbide chips. So we work with the fab companies in developing the next generation chips. We work with packaging companies, package them up, design modules. We work with partners like McLaren and BMW to actually develop next generation inverters and power management for electric vehicles. So in that project, we're doing the power electronics research as well. There's universities too. University of Warwick has got a world-class silicon carbide device development activity, the Professor Filmoby. So we do a lot of the power electronics development in that project, but we also bring together the whole supply chain. So there's 12 different partners in that project in terms of the electronics and the packaging and the design and the semiconductors. So we're developing that whole UK supply chain for next generation EVs. And because power electronics is an underpinning technology, it tends to be, so that's why we're very busy, because it's not just, if you increase the power electronics content in a car, you also need to increase the power electronics content and capability in the charging system. And because you're increasing it in the charging system, you also have to think about implementing power electronics in solid state in the grid as well. So next generation, you can be looking at a solid state grid where at the moment you've got lots of transformers. You can actually eventually have wide bandgap power electronics and converters and inverters for solid state transformers and grid deployment. And then you've got electrification in marine and rail and buses and power electronics for hydrogen vehicles. So it's becoming ubiquitous. So we're at that stage where it's still early days. There's a lot of UK capability, and we're helping position it for global markets. So that's in power electronics, but there's similar projects and activities in other disruptive technologies in photonics and RF. So in RF, for example, if you move to high power, you start to have more and more requirement for, say, base stations and comm systems, or high power radar systems where you actually move to gallium nitride based RF systems, for example. They've got very similar integration and thermal management challenges as power electronics. So we're in a project which is actually developing a UK end-to-end gallium nitride RF capability that is sovereign to the UK. So fab processes in the UK, manufacturing, integration, deployment in the UK as well. And it positions them in a global market too. So obviously, ultimately, you're looking at global exploitation for the companies that we help in the supply chain.
It's really interesting, Alastair. Thank you. So any organisations who are listening to this and think, I'd like to get involved with the Catapult, how would they go about doing that?
You can contact us on the web. We're reasonably easily contactable through LinkedIn and any sort of medium. And it's there's tends to be no wrong door. So if you work with one Catapult, usually they should put you in touch with all the Catapults, start to work together. And we work across a whole range of the supply chain. So SMEs, so startups, we're starting to develop more offerings to be able to support SMEs. So for example, we've got a market intelligence group. So we've done work with companies that start, if they've got a bit of IP in the space, what are the sort of markets they can develop with, or we pull together. So the projects I've been talking about, you can pull together SMEs with the larger companies and the end users and the supply chain, or we're working with university startups, for example. So they can contact us, and we tend to just sort of understand what the needs of the company are, whether that's in business needs or market development needs. And like I say, one of the things we do is get involved in a lot of collaborative R&D projects with government-funded projects where consortia can apply for funding. So we do a lot of support in that regard as well, where we work with companies to understand what their business development direction is, and then appropriately work with them in whatever type of, say, funded space is appropriate to that. Because in some cases it's not. So we're just as comfortable telling companies what not to do rather than what to do in terms of funding. You don't just chase the money. You've got to develop projects which actually tie in very well with your own business development plan, and that's very important. So it might be appropriate for an SME to work in a small, say, a KTP, knowledge transfer partnership with us as a provider within a university in the first place, or it could be in a much larger European collaboration if that's the appropriate thing to do. So we can do that.
Lovely, thank you. And just finally, what are you most excited about in the next year at the Catapult?
End of lockdown. But yes, so I think so the areas that we work in are fast growing areas, and in communications more and more as well with 5G deployment, and there's a big opportunity for the UK supply chain to sort of develop these coherent supply chains and capabilities with lots of different companies coming together, almost as effective tier ones. Now we're seeing that in power electronics, and that's taken several years to develop. You can see that in communications technologies as well. And similarly in photonics and quantum technologies, everybody's talked about quantum for a while, nice word, but in terms of actual, developing that and developing an industrial UK supply chain that can prepare itself for growth, we're starting to see that as well. So in all those areas, we're doing this strong sort of community development at this point, and now we're starting to see the opportunity for industrial exploitation, but still taking all those opportunities through from the academic base as well. So,
that's wonderful. Alastair, thank you very much for your time today. And now we're going to hand back to Mike.
Thank you.